Hello and welcome to the video demonstration of Fast 1.1p. I am Aryan. Let's see the general instructions. The task was to implement a POC of the moon simulation. The surface of the moon can be represented as a square grid of size n. N here is an integer. And we had to create a control application that will simulate a moon rover moving on a square map of dimension n by n. There are no other obstacles on the moon. On the map, the robot is free to wander around the surface of the moon, but must be prevented from falling off the moon. You will see how we have implemented this functionality into our code. Any movement that would result in the robot falling from the table must be ignored by the robot. And we have to implement these functionalities into our code to, to surpass this task. Let's see what our code says. Since this is the basic fast task, we will look at the meaning of each and every word into our code which we have written. Firstly, we have using system. This line is importing the system namespaces, which consists fundamental types, where that is containing fundamental types and classes for basic functionalities such as input and output operations. Then we have created a class. The name of the class is MoonRobo. Here, uh, we all know in C sharp the classes are groupings for for objects, and C sharp works on objects and classes only. Then we have static int and x and y. Let's see what is happening here. This line is declaring three static integer variables n, x, and y, which will hold the size of the map. N is holding the size of the map, and x and y are the coordinates. X we know as abscissa and y as ordinate. Then separately we are defining b as a string, but there is a question mark. Let's see what it says. This line is declaring a static nullable string variable b to hold the direction of the robo, which is initially null. So wherever this question mark comes is a meaning that it is a null operator. Null operator is null initially. Okay. Then we have this line is the entry point of the program which we are writing, static void main, uh, and it is called when the program starts executing. After that, simply we are asking the user to enter the size of the map on the terminal over here. Like this, you can see, enter the size of the map. And also, after that, we have n equals to coordinate 2, 100. This line is assigning the value returned by the coordinate method. It ensures that the input is within the specified range to the variable n. Here we can see in the dashboard also the map must no, must not be smaller than 2 by 2 and no larger than 100 by 100 squares. So we have kept it according to the dashboard only. After that, while true, this line starts an infinite loop which continues until explicitly is exited. So whatever would be true into the terminal as the input, this whole this whole piece or this whole piece of code would be executed. Then inside this we are printing enter a command for the user. Let's see if I enter the size of the map as let's say 6. So virtually a 6 by 6 map is being created, and if I if I if I place any command, if I type any command and it is true, it matches these command, this block would be this block would be this true block while block would be executed. Then we are just printing. After that, we get string command equals to whatever we are writing. It is for reading uh, by the compiler, which we have in the package. Then we get the if command equals exit the environment dot exit 0. What does it mean? The line checks if the user wants to exit the program, in which case it exits the program. Now, to implement this functionality, we are taking use of the switch and break statement. This line starts the switch statement based on the user input command. After that, we have defined cases for place, move left, right, and display, and uh, each case ends with a break. This is the basic syntax you all know. Then if I type place over here, the function of place, which is locate robo, will be executed. And similarly for all of these, if I pla- if I if I give it a command for write, the the function for turn robo will be followed. Now let's see. Now let's see the functioning of these commands. Firstly, we get the locate robo. The functionality is simple. This method is allowing the user to place the robo on the map and specifying its coordinates and directions for X, Y, and directions. Here, the then where we get the move robo. The functionality is this method moves the robo one unit forward, simply moving. Here we are making the robot to move forward in the direction it is currently facing. Then, just like the moving, we have turn robot method. The method is changing the direction of the robot by turning it left or right. The parameters are turn direction, which is indicating whether to turn left, that is for -1, here as you have seen, -1, and for right, 1. Then we have completed place, move left, right, and now we'll see for display. For displaying the location, the current location at which the robot is placed. This method is displaying the current position of the robot only. After that, we we get the coordinate method, in which the method ensures that the user inputs an integer within a specified range. If I uh, if I show you how we can check this, let's let us kill this process and start it from the beginning. So the range was 2 to 100. If I type here 105, it is saying invalid input. Please enter in the integer between 2 and 100. Okay, let's see another function, get direction. This method is ensuring that the user inputs a valid direction, uh, here north, east, south, and west. North, east, south, and west. And after that, we get the valid position method, in which the method is checking if a given position is within the bounds of the map. If we have a map size of 7 by 7 and we are trying to place it at let's say 15,15. So it is logically not possible, and it is taken care. by valid position method. After that, we get the similarly we get the valid robo position. The functionality the functionality it is functioning like the robot has been placed on the map, and it is returning a boolean value indicating whether the robot has been placed. After that, we get the update position method. This method is updating the position of the robot based on its current direction. The let's see how is doing its work. It is calculating the new position of the robot based on its current direction, and then it will check the new position uh, whether it is within the bounds of the map, and then it updates the position if the move is valid, otherwise prints an error message. Here, invalid if the conditions are out of the domain, it will print this message on the terminal over here. Then we get the update direction method. This method is updating the direction of the robot by rotating it left or right. For left, it is -1, and for right, we have set it to 1. But we can place it according to you as well. The parameters turn direction, and the parameter turn direction is indicating whether to turn left for -1 or right for 1. So let's see the proper working of our code. Not net run. Enter the size of the map. Let's say 80. Now let's place the robot and 50. Let's say 50 on it. Now enter the direction. Let's say now. Now we can, let's say we are displaying its position. It is saying 50, 50 and north. Now let's make it place again at 7 and 7. The direction is north. Command would be move, more move, and one more move. Now let's make it move. Now let's turn it right. After that we can display the position. Okay. So the current position we placed the robot at 7, 7, where x is 7 and y is 10. Let's see how. It was at 7, 7. It went north, then it moved to +1, 7 plus 1, 8. Then again it moved 9, again it moved 10. It is at 10 and the direction is east. If I place it again, sorry, if I set the conditions again, dot let run, the size is, let's say, 5 by 5, and we are placing it at 6. So it will say invalid input. Invalid input, please enter an integer between 0 and 5. Since the size is 5, how can we place it at, shall we? Dot let run, enter the size of the map, let's say 55, again place x at 6, y at 6, Right, and right, then move, then press, move. So everything is happening in logical only. Again, uh, so we can now exit the program. I think the demonstration must be clear, and yes, this is all about the task. So thank you.